Hello, this is Woodsmith, and what we have here is a 2x72 belt spinner I built. I was wanting to do a blueprint on this for some time, so I thought I'd put this together. You can see the configuration of this machine is a little different. I wanted to set up a machine with a vertical platen and a horizontal platen, and both a vertical and a horizontal slack belt area. So this is the side profile, the plan I drew up. One should probably give themselves a better blueprint than this to work from, but I had a pretty good picture of it in my head, so this was the plan and drawing. Starting from the bottom, this is the base of the machine. The big red circle we got there is a brake drum off a dump truck or some sort of heavy truck. Those are about 130 pounds, makes a pretty stable base, and then we got a piece of 2x4 square tube for the pedestal and a number of angle iron brackets to mount it all together, and solid 1-inch round for the pivot point for the motor mount. The next fabricated pieces are 2 lengths of 1.5 inch square, which make up the frame of the machine that both support the pillow block bearings for the arbor shaft, and the other 2 tubes you see there are 2-inch square, and with the holes you can see drilled through support the guide rods for the tensioner. This makes a bit more sense if you see it in this view, where you can see how they're configured. Here we have the guide rods for the tensioner. They are each threaded on the end to bolt to the forward frame of the machine, each one having a coil spring to maintain our belt tension. Here you see they're bolted to the forward frame, which is a modified piece of angle iron that supports both guide rollers and the front vertical platen. I machined out 2 rollers like this, each being a little over 2 inches wide for our sanding belt and 2 inches in diameter. There's a shoulder board in there to receive an 1 3/8 bearing with a 1/2 inch ID. And here we are pressing in a set of high-speed bearings into those aluminum rollers that we've just turned. Okay, here I've got a 3/4 inch shoulder on the arbor shaft of the machine to receive the drive wheel, and we've drilled and tapped the end to install a bolt to retain the drive wheel. The opposite end of that shaft has a set of left-hand threads for a deburring wheel. I figured we might as well use both ends of that shaft just for makes sense. Next up is the drive roller itself, being 4 inches in diameter, and bored and broached to fit that arbor. The crown on there is, I think, quite critical not to be overlooked if you want your belt sander to track. I looked up the spec for that officially in Machinery's Handbook for that diameter wheel and that width of belt, so that got the crown right and machined that in. Okay, this is the tracking adjustment I devised, which is a simple stainless Allen bolt tapped through the end of that 1/2 inch axle shaft for the upper guide roller, so it can either push or pull the upper guide roller to allow the belt to track. It works pretty well, but it would probably work even better if it were on the bottom roller, because as you use the upper slack belt area, you add tension to the belt in there, and that does affect the tracking somewhat. I had to build a tension release of some sort if I wanted to be able to change belts with any sort of normal human effort. So here we have a aluminum clamping block along with a cam lever. You can kind of make out the eccentric point there on the cam lever, and we do have sort of a breakdown of the 2 parts used to achieve that. Here we have the motor mount, which is a basic gravity belt tensioning type motor mount, and allows us to move the motor left or right enough to use the step pulley to give us the speed ranges we want, and I did calculate that out to give us the number of speed ranges you would want for various number of grits of sanding belts. We also have the toggle switch on top for on and off, the way I mounted it, and there is a reversing switch on that motor to allow us to use that buffing wheel from the opposite side of the arbor. Now I should definitely point out that I was taking a machining class when I built this sander, and I was rather intentionally doing more machining than I normally would. Anything else I built in my shop has little or no machine parts because I wouldn't normally have access to that type of precision machinery. I'm a huge advocate of improvisation and various different forms of junkyard builds, and I also know there are more perfect belt sanders than this out there, and I still figured there was probably a couple of points in this build that would be of use to anybody looking to build their own machine, and I hope you can find it useful for your next project. Thanks.